Simon, this machine here, this LUMEX Advanced 25, this is a 5th generation hybrid machine, isn't it, from Matsuura? What's new on the 5th generation?
Okay, so yes, this is the hybrid machine, and what we've done with the new 5th generation machine is to increase processing speeds. Basically, this is coming from a higher powered laser, also new parameters for processing the materials, and also processing capability from the machining side has been improved with our powder removal function.
So when we say hybrid, for people that haven't seen previous videos that we've done, we're basically talking about an additive manufacturing machine that's got the machining capability as well, aren't we?
That's correct, yeah. So Matsuura's hybrid technology basically is to look at the additive technology and see how we can sort of further progress the processing of that part to get closer to a finished part in a single process on a single machine. Yeah.
And one of the things about the 5th generation that you've mentioned is that it's got advanced technology, it's faster. That's always been a bit of a drawback in some people's eyes for additive manufacturing, the fact that it can take a long time to make a part.
Correct, yes. Also for our hybrid technology, we compared to the additive only machines as well, yeah. So we have to prove the benefits of the hybrid and the added time, if you like, for processing the individual parts compared to the benefits that are achieved.
Tell me about the laser. You said this is a higher powered laser in this 5th generation machine.
Yeah, so up until now we've been using a 400 watt fiber laser. This machine has a 500 watt fiber laser as standard with an option for a 1 kilowatt laser.
And what does that mean by having the higher kilowatts?
Well, basically for the additive function, it all depends on the energy deposition or the energy you can impart into that material. So if we have a higher powered laser, we can impart the same amount of energy in a shorter period of time. This allows us to scan faster and process faster.
Okay, now this is very interesting to me, this what you're holding in your hands, because this really does demonstrate the difference between what you're doing here with this technology and what maybe just a normal additive machine would do. Is that correct?
That's correct. What we have here is basically a sample work from one of our partners, which is Panasonic Corporation. And what we show on the right-hand side here is what we would normally expect from an additive-only machine. As we can see, there's no machine finish here. This is just the laser finished surface. What we're aiming for with the Matsuura additive hybrid process is to be able to finish machine these parts in the single process.
Now, what you're not doing is doing all the additive and then machining at the end, are you? You're machining throughout the process.
That's correct. This is where the advantages of the hybrid technology sort of can be realized. So what we do is lay down layers of powder and we selectively melt these exactly the same as a normal SLM machine. After we've done that for a standard process of 10 times, then we would go in and do a single machining process. But then we would restart the additive, continue to build up the part, more machining, more additive, more machining. What this then allows us to do is to access areas of the part that we wouldn't normally be able to access if we were doing a finished part.
And it makes the final component's accuracy far greater, doesn't it? Because it's what you're machining to the finished part.
Yes, one is the accuracy. We have an overall accuracy for this process of plus minus 25 microns within the whole of the build area. But the other thing that it allows us to do is to create parts in a single piece. So with the normal or conventional processing, many of these parts, particularly in the mold tool applications, would be made in multiple parts simply so that they could be machined. And quite often as well, they would be using the EDM machining, which we are able to eliminate with this process.
It's a total change of thinking, isn't it? What about materials? We talk a lot about additive manufacturing and the types of materials that you can print essentially. What is there any restrictions here?
Basically, we can develop the powders for use on this machine. We have 7 standard release powders, if you like. These are available for customers to use now. We would provide the parameter sets both for laser processing and for machining, and so these would be ready to run for the customer. Any other materials would be sort of on a development basis with Matsuura.
So you say you have 7 powder sets. So what it's doing is it's mixing different amounts of each powder in order to create your ultimate material.
No, sorry, these are single materials for processes. So these are individual materials for each of the required applications. So for example, with the mold tool, generally we're using a marrow aging tool steel.
And so stainless, titanium, whatever it might be, it's capable.
Yeah.
Interestingly as well, I've seen an engine block. This is quite a small example of what you've done, but that's because this machine, as the 25, has got a smaller envelope, hasn't it? You've introduced a newer machine which is much bigger, that you can do bigger components.
So basically the LUMEX Avance 25, this refers to the build size, and with the 25 we have a 250 millimeter by 250 millimeter build area. With that, the build heights are either a 185 millimeter height with an option for 300 millimeters. But now, like you've just said, we also offer the LUMEX 60 machine. Now, the LUMEX 60 takes the possible build size up to 600 millimeters by 600 millimeters with a 500 millimeter height.
So it's opening up completely new markets for you with that machine, isn't it?
That's correct. I mean, the smaller machine, really, we are very much targeted at the mold tool industry. But with the larger machine, the larger capabilities, then we're looking at, obviously, much larger work sizes, but also different applications in the aerospace and automotive industries.
Is there a lot more advancements to happen? I mean, we talk about this machine here being the 5th generation. Is it moving so fast that soon there's going to be a 6th and a 7th generation? If so, what would those things be?
Well, I'm sure Matsuura would keep up with the developments. In terms of the industry as a whole, then there's a lot of effort and development in terms of design for additive, design for hybrid, and also the simulation of how to make these parts right first time.
Good stuff. Thank you very much, Simon.
Yeah, thank you.